Hey guys, this is Coach Brian. I will be working on part 2 of the 1.1 through 1.3 quiz review. These questions were just recently added, so they won't be in part 1 of the review videos. So I'll be starting on number 15. I'll do all the way through the end, and then the other first 2 pages, 1 through 14, can be found in the video part 1. So to start with, we added in this skill of chart reading, okay? And so you have to, identify what's in the table. We've got a list of inputs, and then we've got function f, and we've got function g. And so what it's saying is when I put this number in to this function, this is what I get out. So it just asks us to identify a couple of things. For instance, it asks us to find what do you get when you put 0 into function g. So I would go over here to 0 on my inputs. I would go down to row G, and I get out a 1. Same thing for this next one. It's asking what do I get when I put a -2 into function f, and I get out 9. And then lastly, it says find e if g of e equals -3. So it's asking what's your input to function g if your output is -3. So we'd go down here to function g. We'd go all the way over to -3, and we actually have 2 locations where our output is -3, and that's okay. Multiple inputs can have the same output, but an input can't have multiple outputs. It would fail the vertical line test. It wouldn't be 1-to-1. So our answers here, E would equal, you can see we got -2 and +2. So I'm just gonna write it like positive or -2. And your guess could be that this is some kind of quadratic function maybe. Put in a negative, get out a negative, put in a positive, get out a negative. It looks like it's mirrored to some degree, so it could be a quadratic or an absolute value of some sort that is obviously flipped. There's still 2 more right here. 18, it says find A, so your input, if your output is 5. So similar to question 17, we're going to go up to row F, and we're going to find where does it equal 5. And what did I put in to the function to get there? So A would equal 0. And then the last one we have composition function. So first we need to figure out what f of 3 is. And when you put a 3 into function f, you get out -1. And so now we're going to take that and input it into function g. Okay, so it's like you have to find this result first, and then you input it to the next function. So when I go over to -1, and I see what do I get when I put it into function g, I get out 0. So I feel like those are pretty straightforward. The ones that can be confusing are the composition functions. So you just want to work those from the inside out. The next section, 20, 21, and 22, we're looking for domain. So we have certain rules that we need to identify, and I'm actually going to start with 21, the radical, and what's underneath there is called the radicand, and it cannot be negative. Cannot be negative. And then I'm going to look over here at 22, and we have our input in the denominator, and it cannot equal 0. Sorry, I got used to using my other program where I can erase quicker. Cannot equal 0. All right, so question 20, the reason I saved it for last is because it has both. It has radicand, or I'll say a radical in the denominator, And when you have that, you have to follow both of these rules. Cannot be negative. And cannot equal 0. So we'll again start with 21, do 22, and do 20 last. So for 21, you want to actually write out what this says. You want to write out 1 minus x cannot be negative. So I need to write that it is greater than or equal to 0. And then you just solve this like any other inequality. You would, in this case, I'd add x over to the other side, so I wasn't messing with any negative numbers. And I would have x is less than or equal to 1. Less than or equal to 1. And if you think about it, if I subtracted anything bigger than 1, 2, 3, 4, 5, 6, 7, 8, on and on, this is always going to be negative. But if I subtract any number that is 1 or less, I follow my rule up here and I'm good. So another way you could write that, instead of just, x is less than negative 1, you could say that x is from negative infinity all the way up to 1, and 1 is included. For 22, again, you want to write out what this says. So I'm literally saying x plus 2 cannot equal 0. And then you would solve this just like an inequality, or any equation or inequality, you would move over the 2. And so you're saying x cannot equal negative 2. It can equal negative 3. It can equal negative 1. It just can't equal negative 2. So you could write that, again, in interval notation. You could say it goes from negative infinity up to negative 2, which is not included. And then you have a union over to negative 2, and then all the way up to infinity. Last one, question 20, we have to follow both rules. So we're going to say 2x plus 1. It has to be greater than or equal to 0, but then we're saying it can't actually be 0. So if we're following that first rule, it would look like this. And then we're saying, actually, no, it also can't equal 0. So what we need to do is we need to actually remove the or equal to, and now we're ready to solve this guy. So we would subtract our 1 from both sides. We have 2x is greater than negative 1, and then we would divide by 2. And so we're saying x is greater than negative 1 over 2. And again, you could write that as negative 1 over 2, not included, all the way up to infinity. And so that is how you find the domain of these kind of like red flag situations, radicals and denominators. So hope this helps, and good luck preparing for your first quiz.